he denied and kept with him in all of his lectures conducted around the world. This is the web. This is how the pictures of network theory are done. With it, he can explain many different scientific disciplines, from chemistry to information systems, and of course mathematics and biology and stuff.
Today, good over to YAO.
It is also widely known that there is a small and modest number, often referred to as a number starting with the digit 3. It is comparable to a decimal number, not 3.14, but it does not come to an end there. It continues on indefinitely without any finite conclusion or termination point, stretching infinitely into the realm of numbers and decimals, with no discernible pattern or repetition to its digits. This is a pi that everyone surely knows for sure. However, there are specific aspects that serve as a sort of comprehensive reflection of our existence, our planet, and the world as a whole. But there are things that kind of tell everything about our life, our planet, and our world. So basically, pi means the quotient of a circle's circumference and its diameter. So it won't become a whole number, but 3.14 and an infinite number of decimals that can't be predicted in advance. So we have whole numbers, then we have fractions, which we have exactly, and decimal numbers to indicate fractions as well, meaning divided by 10. But then we have, these are the rational numbers, but then there are irrational numbers, and pi is one of them. There are not a significant number of them. Consequently, an irrational number is a number where the decimal part never ends, and it is impossible to predict what the next digit will be in advance. And they've been trying to calculate it in many different ways. So basically, it's the circumference of a circle divided by its diameter.
We've tried to compute the torture value in different ways, mate. One of these doesn't go farthest, a bloke called Ludolf. Okay, let's change the circle to a polygon, like a bloody hexagon. Calculate areas of 6 triangles. Calculate area of 6 triangles. Then we'll chill out more. Let's make an octagon, a dodecagon, a hundredgon, and so on. Ludolf was a bloke who spent his whole life calculating the value of pi like this. The value kept getting more and more precise as this went on. It was bloody hard yakka. In the past, in Pieter, it was also called Ludolf's number, carved on his tomb. I wouldn't advise, mate. We have probability calculations. It's a classic Monte Carlo method, mate. Monte Carlo is a simple method to explain, mate. So we will take a spot in the sandpit, where it is easy to count by 4s. After that, we'll draw a circle inside it, following the edges. Then we grab some rocks or balls, go further away, and chuck M into the sandpit. After, we'll go and see how many people hit inside the circle and how many outside. We can calculate the circle from that, roughly the size of the whole circle. And the more rocks they throw, the closer it's likely to get to the value of pi according to the formula.
Sure. In this particular location, we can observe the presence of a sandbox, with a circle that has been drawn precisely at the midpoint of it. And there is the radius of the circle, denoted as r, and of course the length of the sandbox's border is equal to twice r, which is equivalent to 2 times the radius. The area of the sandbox is 4 times the square of the radius, and the area of a circle is x times the radius raised to the power of 2, so x is equal to pi. Now when we throw rocks in there, we get some kind of understanding of how many rocks are inside the circle and how many are outside but inside the square. And when we get into this relationship, the relationship is one variable or parameter in it, so we can include it in the equation, and then that x can be solved like that. In that case, the PRT disappears, meaning the rays disappear completely. And there you have it, pi is 4 times that ratio. The more rocks are thrown in there, the closer it comes to the torture value. Give it a try yourself, even on the computer.
This seems crazy, but the method is used in things like a cyclotron, which is a particle accelerator, to calculate the sizes of elementary particles. The famous Higgs boson was discovered with this. So, the Higgs boson. Info based on prob calcs. Ponder it, buddy.
Well, these were the intelligent men. Well, have a wonderful day with your pipe, everyone. I am currently in pursuit. What about pi in multiple dimensions? Is it even possible? In a three-dimensional space, we can visualize a sphere. The sphere is associated with a ball that has a diaper for added convenience and hygiene. And the relationship between a diaper and a puck started by a ball corresponds to three-dimensional silicon. Now we've got a formula ready for calculating the volume of the ball. And not just an ordinary ball, but also a four-dimensional ball and a five-dimensional ball. And an n-dimensional sphere, and the formula was never completed. And let's not forget the value of pi in the third dimension. Interesting, it turns out to be a rational number. Clear? Well, it's because there are two pi values involved which cancel each other out. Then we enter the fourth dimension. In this dimension, you have the ability to calculate the ratio of a four-dimensional NS envelope to the sphere contained within it using the same method, which essentially involves a starting disk within that four-dimensional sphere. Here we go again, another irrational number. And this is how we can keep moving forward. Well, what's interesting is that there's more to it, something we are not aware of, because when you count a larger number of these tormentors, the pin value increases by 3.14 upwards, reaching 4 and continuing to 5. However, during the Tetzer phase, the curve turns downwards, but the pin value doesn't start decreasing. Just a little clarification.
The pi is not decreasing, but the ball.
It is going to be a curve that rises and falls. The intriguing aspect is that this change occurs in the dimensions of the fifth and seventh, depending on the gauge that is utilized for measurement purposes. But starting from the fifth dimension, this branching out. And once again, this is related in a certain way to the field of quantum physics and Einstein's theory of relativity, and how they are interconnected with Kaluza's theories. So, before Einstein came up with his current theory of relativity, there was a long-standing assumption that gravity is somehow related to the fourth and fifth dimensions, and that they are interconnected. So here is something deeper, something that might actually be related to the entirety of the universe and our overall